Alright, let's take about 10 minutes and look at some examples with momentum. Okay, so this is just kind of introduction. We'll do some easier problems and just kind of give you an idea of how it works. Okay, so here's my initial problem, projectile launcher shooting a projectile, and it's asking about the recoil velocity of the projectile launcher. Now we know that this is going to be dealing with momentum because we're dealing with two objects, right? And so we know that the sum of the momentums initially is going to have to equal the sum of the momentums finally. Okay, so now if we take these and we say, okay, initially I've got the launcher and I've got the projectile, so that means the mass times the velocity of the launcher initially plus the mass times the velocity of the projectile initially has to equal the mass times the velocity of the launcher in the end plus the mass times the velocity of the projectile in the end. Okay, so let's go ahead and put in the data that we have. We know that the launcher has a mass of 5 kilograms and that at the beginning it's at rest. The projectile has a mass of 209 grams, which is 0.209 kilograms, because we want it to be in kilograms, times its initial velocity, which is 0. Okay, so initially everything adds up to 0, right? Everything's at rest. So in the end, the mass of my launcher times its velocity, which is unknown, and then I'm going to add on the mass of the projectile, which is 0.209, times its speed, which is 350 meters per second. And when I take that and work it out, then I know that initially it's 0 equals 5 times the velocity of the launcher, which is what I'm looking for, plus 0.209 times 350, so 0.209 times 350. So that is 73.15. I'll subtract that to the other side, so I'll have negative 73.15 is equal to 5 times the velocity of the launcher. Divide both sides by 5, and we get 14.63. So negative 14.63 meters per second is the velocity of the launcher. Now it's negative because I said that my projectile is moving in a positive direction. So if it's moving in a positive direction, then that means in order to conserve momentum, the gun has to be moving in the opposite direction, which is going to be negative. Alright, let's go ahead and look at another one. So now we're looking at a perfectly elastic collision, which all that means is that when it gets down to it, the two objects are going to stick together. Okay? So what will be the result if a 65 kilogram sprinter going east at 10 meters a second runs into a 75 kilogram sprinter running north at 9.5 meters per second? Okay? So essentially we have to conserve the momentums. All right? So initially we can look at both the horizontal and the vertical momentum. All right, so let's look at the horizontal momentum first. Okay, so if I look at the horizontal momentums, I've got the 65 kilogram sprinter that's running east. So if we consider north, south, west, east, east is to the right, which is positive. So initially he's going mass times the velocity going east, so that will be positive. And then the 75 kilogram sprinter is going north, so it doesn't have any it doesn't have any horizontal momentum. Okay, so this is of the first guy. That will equal, now in the end, they're both going to be moving in the same direction. So in the end, either you can treat it as one object, right? We can say, well, now my object has mass 1 plus mass 2 times the final velocity, so you can treat it that way. Or if you want to treat them individually still, kind of like we did in the gun problem, in the projectile launcher, you could do m1 v final plus m2 v final, which you can see if we factor out the v final, it gives us this. Okay, so essentially we've got one runner that's going completely horizontally, and then when they run into each other, their mass is going to increase, but the horizontal momentum has to be the same. which means obviously if the mass is increasing, the velocity is going to have to decrease. So let's look at that. We've got 65 kilograms times 10 meters a second, which is going to equal to 65 plus 75 times that final velocity, which we can now solve for on our calculator. We'll go 65 times 10, and then we're going to divide that by 65 plus 75, and we get 4.64. So the final velocity in the x direction is 4.64 meters per second. All right? So now we know the horizontal. We can do the same thing vertically, right? Vertically, the first runner is going directly horizontal, so he won't have any vertical, right? You could write it as m1 v1, but the initial velocity vertically for him will be 0, okay, plus the mass of the second guy times his velocity initially. And again, when they collide, they're going to be together. So the mass of the first guy plus the mass of the second guy times their final velocity vertically, right? So the second mass will be 75 times its vertical speed, which is 9.5. That will equal 65 plus 75 times the final vertical velocity. And so we got 75 times 9.5 divided by 65 plus 75, and we get 5.08. So velocity final equals 5.089, so 0.9 meters per second, and that is vertically. And so when we then consider what overall is happening, we've got a horizontal velocity of 4.64. We've got a vertical velocity of 5.09, which means if we put those together using Pythagorean theorem, then it will be the square root of 4.64 squared plus 5.09 squared, which gives us 6.89. So 6.89 meters per second. We can get that angle. I'm going to use tangent, opposite over adjacent. So tangent inverse 5.09, opposite over adjacent 4.64. I'm assuming that you're able to do the trig and the other stuff now. If you're having a hard time with that, you may want to go back to one of my other videos that looks at the vectors and the trig. But I imagine you're okay with that. So 47.65. Okay, so the result is that they will be traveling at 6.89 meters per second at an angle of 47.65 degrees, or 47.65 degrees north of east. Okay, so there you go. You've got one that's just all in one dimension. This one is taking two dimensions and putting them together. All right, also taking the idea of them sticking together, and so essentially you are creating a new object with different mass. Or, like I said before, you can treat them separately and just understand that then you factor out the final velocity, because in the end they're both traveling together, so they'll have the same horizontal velocity there. All right, and then I will actually create another video where I do this other one. So good luck. If you need it, watch the other one. If not, then go for it.